Okay, number 7 asks us, when you reflect a figure across the y-axis, do the x-coordinates change or remain the same? And the best way to answer a question like this is to just draw a little sketch of a coordinate plane, draw a figure, and imagine that if you reflected it across the y-axis, what would happen to the y-coordinates? If we reflected that across the y-axis, for each vertex, the y-coordinate does not change, but the x-coordinate changes from negative x to positive x, changes to its opposite. So if you reflect across the y-axis, the x-coordinates do change. When you reflect a figure across the x-axis, number 8, it's asking, do the x-coordinates change or remain the same? Well, we have an example of that in number 6. We reflected across the x-axis, and our x-coordinates did not change. They all stayed the same, which makes sense. We're flipping it over that axis, so the y-coordinates change to their opposite, but the x-coordinates remain the same. Number 9 is asking us, when you translate a figure to the right, do the x-coordinates of the image increase or decrease? Well, if we're sliding to the right, the x-coordinates are definitely going to increase since we're going right on that number line. Number 10, find the value of the angle x in the triangles below. The first thing we need to remember in order to do this problem is that the sum of the angles of a triangle equal 180 degrees. And hopefully that activity we did in class where we tore off the angles and put them on a straight line will remind you of that. We tore off the 3 angles and they made a straight line, so that's 180 degrees. So we need to add up the angles we know and subtract from 180. 51 plus 90 equals 141. So x would be 180 minus 141. 10 minus 1 is 9, 7 minus 4 is 3, 39 degrees. And let's just check our work. Let's add 39 to this 141 and make sure that equals 180. 1 and 9 is 10, carry the 1. 1 and 4 is 5, and 3 is 8. Yes, 180, that checks out. Okay, this other triangle, looks like we only have one of the unknown angles, but really, if you remember that isosceles triangles, the angles opposite the congruent sides are also congruent. So this angle x is equal to this other angle x. So we have, first we need to subtract the 32 from 180. So we have 148 degrees between these two angles, but since these angles are equal, we can just divide by 2. So each angle x is 74 degrees. 2 of them would be 148, and then you add the 32, you get to 180 degrees in a triangle. Number 11 asks us to find the value of the angle x in the quadrilateral below. Now in quadrilaterals, the angles add up to 360 because you can take any quadrilateral and draw a diagonal and break it up into 2 triangles. So 2 180s equals 360. Or you can remember the activity we did where we tore off the corners and they made a full circle. So we add up the angles we know, 130 plus 90 plus 90. We get 310. So this x must be 360 minus 310, or 50 degrees. 50 plus this 130 would be 180, and this other 180 would be 360. That adds up to 360. So that checks that answer. And it looks like a reasonable measurement for that angle. We can see that it's an acute angle. Okay, we'll pick up the review with problem 12 in the next video.